Hi everyone. So in this video, I want to discuss a little more details of tree-based methods. So this is an example of tree-based method. We want to determine the salary of baseball players by some other variables. So to determine salary, the most effective way is at first to see the number of years of experience. So if the number of years of experience is less than 4.5 years, yes, then average salary is here. And if more than 4.5 years, then we have another criterion. So whether or not hits are less than 117.5. If yes, then average salary is 6.0. If no, then average salary is 6.74. So we have the three result. So these are called no's. And this entire figure is called tree. Okay, so this is the more detailed explanation. So regression tree that splits the predictor space with single predictor at each step and fit a regression, typically just a constant in each region. So each node corresponds to these three regions. So splits are made so that the sum of squared errors is minimized. So how to determine these splits? Actually, this is chosen to minimize the sum of squared errors. So each observation has salary here, and we assign some constant C1. Then we can compare each observation with this C1. Then we can calculate the error. So we determine the threshold to minimize the sum of squared errors for all observations. And when we stop splitting the tree, and we need some criterion. So basic idea is just we make very large tree. So we split as much as possible. But we have to stop at some point. So we define a certain number of observations, such as 3 or 5. Then we can stop if all nodes have less than that number of observations. So this is another illustration for tree with 5 nodes. You can see that we have the 1, 2, 3, 4, 5 regions. So this is a tree with 5 nodes. And how to determine the size of tree? We have created very large tree, but we have to optimize the size of the tree. And idea is this. So at first, the first part is the error size, and the second part is the penalty for more complicated trees. So we balance between error size and the simplicity or complexity. So given alpha, that we can minimize this quantity to determine the tree. So how to determine this alpha? So alpha is a hyperparameter, so it is usually determined by cross-validation, such as tenfold cross-validation. So alpha is denoted as k in the tree library in R. We will see in the next video. So once alpha is determined, we maximize the objective function. Actually, this is minimize. This function to optimize the tree. So optimal tree is a subtree of the tree obtained in the previous slide. Maybe the full tree, the large tree, includes maybe 20 nodes, but the subtree is simplified, so it may only have 10 nodes. So making a subtree is called the pruning. Okay, so this is a summary of building a regression tree. So at first, make a large tree based on the algorithm to minimize sum of squared errors. Then estimate alpha by cross-validation. then prune the tree to get the optimal tree. Even with this procedure, often tree-based methods suffer from overfitting. So training error is very small, but test error is actually very large. So therefore, it is recommended to use validation approach, that is the making training and test set, or cross-validation to evaluate test performance. So we use one cross-validation to estimate alpha. So actually, if you use cross-validation here, the cross-validation is in 2 steps. So we have to do 2 cross-validations to estimate entire model.